I built this drowsiness detection system using OpenCV and eye aspect ratio, and there is another library called face predictor 68, which means it has a 68 points on the face. It is predefined and pre-trained model, and we'll use that pre-trained model in this drowsiness detection system. And why drowsiness detection system? Because it has a very practical implication in real world. And there, according to research in India, every year approximately 30 to 35% of accidents are caused due to drowsiness of a driver. And let's see how this model works and what are the disadvantages of the model and what's the main algorithm that we are using in this model. Coming to the advantages of this model, it is very simple and very easy to use, easy to deploy, and it can be used in vehicles, and it has a vast practical implications. Let's see what are the disadvantages of this model. As you can see in the green text, it says eyes and 0.35, 0.34 something. That's actually the ratio. So as you can see, if I increase my eyelids, and the ratio is going up, and if the ratio is below 25, then it will trigger a beep sound, then it will say drowsiness alert. And imagine you are driving and you are feeling drowsy, and due to the beep alert you may wake up. Let's look into the disadvantage of this model. As you can see, it completely works on the eye ratio, and eye ratio is not same for almost every races. My Chinese friends, their eye ratio is below the average person's eye ratio, so you have to customize the eye ratio, depends upon the place and maybe depends upon the person's eye. And another disadvantage of this model is it cannot really detect your eyes. Then how does it know that you are sleeping or not? Now I'm literally closing my eyes and it cannot detect the ratio, and it doesn't give the beep sound. You can also integrate this with infrared cameras. You'll get the night vision, and you can detect the eyes in the black, grayscale images as well. It has no issues with that. And another disadvantage is if I'm looking for something really quick, look, it has a beep which is disturbing. You can also customize this, and you can improve this model. I'll show you in the further video. Since driver has to focus on the road completely, and I made this model so sensitive, but you can also adjust the sensitivity and tune according to your needs and necessities. Okay, and let's see how this model works. And it's very simple, it's just 100-line code, and let's see. Yeah, that's it. It's just 97 lines of code. And the reason behind this simple code is because I downloaded this pre-trained model directly from the GitHub. So why don't you leverage the pre-trained models and simply integrate with your existing current idea to make it more simple and less code heavy. So let's see how we integrate this model with our current Python code. This is a threshold that we are setting up, 0.25, which means if your eye ratio is below 0.25, it will give you a beep sound and drowsiness alert, and that's a 20 frames over there. And it's a very simple line of code. It will just work on if else statements. So if the eye ratio is below 0.25, then give beep sound, and if it stays long as 20 frames, give the beep sound. And we are fetching using these. We are fetching eye points using these directly from the face predictor 68, and then we are calculating the eye ratio over here. And we're just calculating the eye ratio over here, and then we'll just go through the if-else statements, and if the eye ratio is below 0.25 for this particular frame rates, for example 20 frames that I have given, then it will give you a beep sound and then it will alert the driver. That's it. You can check, you can go through this, and I used wind sound, and you can adjust the frequency. Go through the model, try to understand it completely, and check around and tune it if you want. Hope you like the model and the video. Thank you for watching. Links will be provided in the description. Thank you.